Major financial institutions are sitting on the edge of the blockchain space. They're looking at networks that offer instant settlement and sub-cent fees, looking for a way to safely deploy trillions of dollars in institutional capital. But they all run into the same exact problem: privacy. Blockchains are built to be transparent. Every transaction, wallet address, and timestamp is permanently recorded for anyone to see. For a global bank or an asset manager, operating in total transparency is impossible. They cannot broadcast their strategic trading moves to competitors or expose sensitive client financial data to the public. Until these institutions can maintain confidentiality on an open network, their move toward on-chain finance remains stalled. The first attempt was the shielded pool. Users deposit funds into a shared smart contract to mix them privately. It works mathematically, but legally, the contract is classified as a custodian. The developer becomes a money service business, liable for intensive compliance. Solving the technical problem of privacy accidentally triggered a regulatory collapse, rendering the technology unusable for licensed institutions. A new infrastructure layer on the Stellar network, called Pakana, takes a different approach by redesigning the transaction itself. The system operates on a single principle: provide the tools to verify a transaction's validity while exposing none of the underlying data. To achieve this, Pakana splits the process into two separate tracks, ensuring information never touches the money itself. Unlike shielded pools, funds stay in separate pathways, bypassing any central commingling contract, removing the regulatory point of failure. This structural separation is what allows for privacy by design, without forcing the software provider into a custodial role. On the settlement track, funds move directly to a single-use stealth address. The platform never holds these funds. Simultaneously, the signal track sends an encrypted zero-knowledge proof, which unlocks and authorizes the recipient to claim the funds. Processing these two tracks in real time requires a significant amount of computational overhead to maintain the cryptographic proofs. Pakana handles this through a core engine built in Rust and YadaDB. This backend provides the processing power to verify these cryptographic proofs in milliseconds. This processing layer allows the system to facilitate secure, private transactions without ever acting as a financial intermediary. By removing the central pool, the system operator is classified as an infrastructure provider rather than a money transmitter. Because they only facilitate the encrypted signal and never touch the settlement track, they don't meet the legal definition of a custodian, bypassing the regulatory trap that stalled previous privacy projects. This architecture addresses specific legal hurdles. It satisfies the Genius Act because the operator lacks the physical power to move or freeze user funds. It aligns with UCC Article 12 because legal control of the asset stays with the user's private credentials. Furthermore, it satisfies GDPR by using zero-knowledge proofs to verify attributes like age or residency without ever storing the raw identity documents. This removes the risk of a personal data breach. In real estate, this allows for tokenized payments with an immutable audit trail for every dollar moved, but because the software provider never takes custody, they carry no liability for the escrow. In healthcare, institutions can verify provider credentials or patient consent across different organizations. The proofs confirm the data is valid without the organizations ever having to share or store the raw, sensitive files. This system also enables instant cross-border USDC payments, which can be settled at physical locations through MoneyGram's global network. Throughout these transactions, the legal control of the asset remains with the end user, not the platform. By separating the information layer from the value layer, Pakana has created a framework for how institutional finance can finally operate on a public blockchain.